Yet another solid revolution on exercise 3. Find the volume of the solid revolution formed by revolving the rectangle shown around the y-axis. So not both of them this time, just the y-axis. And notice that there is a space that's right here that didn't exist on the previous question, right? The rectangle used to be just smack against the axis that we were rotating it around. So this time it's off of the axis. So what shape is that going to make whenever it rotates around here? So think about this. Think about the fact that this hole that's right here, that shape is a rectangle. And if you rotate that rectangle around, it would create a cylinder. Now think about if this whole thing was covered up there as this one large rectangle. Actually, what would it be? A 6 by 6 would be a square. If you rotate that thing around, it would make also a cylinder. So what we have here is a cylinder with a cylinder hole in it. It's going to be sort of like a roll of paper towels or something like that. So it's going to look like this. I'm going to draw my large cylinder. Okay, and then it has a hole in it, and that hole is coming from this white space that is also a rectangle, like this, that rotates around, and it cuts a hole out of the inside of this, sort of like that. Can you visualize this as like a roll of paper towels, or maybe even a toilet paper roll? I mean, whatever. Okay, so here we've got a picture. We can see what this thing sort of looks like here. Maybe I even add a little bit of shading on this one to the top. That looks great. It's marvelous. Now, I need some measurements on this thing so I can calculate its volume. I have a couple of points here. Oh, wait, before I do this, I'm going to draw in this segment and this segment because there is the rectangle that I rotated around the y-axis in order to generate that solid there. Okay, that's kind of handy. And the reason why is because, look, I've got some numbers here. The 6 as the height, that's going to be the height of my cylinder. I'll go ahead and write that on there. And I can see here down here at the bottom, this needs to be 2 because we're going from 4 up to 6. So that part there is 2. That's the width of that rectangle. But right now, that's not terribly helpful for me. And the reason why is because if I'm going to find the volume of this thing, in general, what I can do is this. I take the volume of, let's say, the larger one. I'll say that V sub L. And I'm going to subtract out the volume of the smaller one, V sub S, in order to get the volume of my paper towel roll. So there's kind of the strategy there. So I need 2 radii. I need the radius for the larger one, and the larger radius is going to be from the y-axis that we're spinning it around all the way to the edge here, which is 6. So it's from here to here, that radius is 6. And then I need to subtract out the hole, and the hole for the smaller one has the radius from the y-axis to this very first point. That radius there is 4. And that's this one right here. Here, actually, let me move this up a little bit. And then have a little bit of extra space in order to put the 4 there for this one. Okay. All right, now we got a plan. We're going to take volume of the large one and subtract out what's the volume of the smaller one in order to find our paper towel roll. Pi times the larger radius was 6, so 6 squared multiplied times the height, which was 6, and then we'll subtract out the smaller one, which has a radius of 4. 4 squared times 6. Okay, so here I've got 36 that I'm multiplying times 6. 36 times 6, let's see, that's 36 again, and 18, 216, 216. Throw some pi on it, and then over here we have 16 times 6, which I think that we already did. That is 190, or no, just 90, minus 96. Pies. All right, subtract them. minus 96 pi. 6 will cancel, and we'll get 20. How about, whoops, 120. Yeah, that sounds way better. 120 pi's. So here's our volume in cubic units. You know what? This is not the only way to have done this particular problem. And the reason why is because as a cylinder, which is also sort of like a prism with a circular base, you could find its volume by area of the base and multiply it times the height. It's just that our base shape, if I draw it from the top view, is a circle with a hole in it. So if I just find the area of this circle with a hole in it, I can multiply it times my height of 6 here, and I should get this exact same number. So let's check it. Let's see how that works. Again, whoa, stop freaking out on me. My 2 radii, my big one here is 6, and then the smaller one is a 4. So the area of that base should be equal to pi times the 6, which is squared, minus pi times the 4, which is squared. Hey, that looks sort of like what was going on in that other calculation. I got 36 pi's minus 16 pi, which I do believe is 20. I've got 20 pi's. There's the area of the base. And if the volume is the area of the base times the height, I take this 20 pi, multiply it times my height of 6, and in fact, I do get 120 pi, again, units cubed. Notice also that I could have gotten that from this calculation here if you factor this 6 out. When you factor this 6 out, it becomes this step right there. And then you multiply it by 6 at the very, very end.